Good morning and welcome to Rethinking Heat with Thermal Energy Networks. I'm Diva Scoville, Associate Manager for Programs at Urban Green Council, and I'm excited to welcome you all to this webinar today. I'd like to introduce the Urban Green Council values. They are excellence, inclusion, collaboration, and engagement, and they guide all of our programming. I'd also like to thank our sponsor, Con Edison. And with that, I'll kick it off to Janet Joseph, who will be moderating this conversation today.
Good morning. Thank you, Diva. It's great to be here and moderate this session on rethinking heat with thermal energy networks. So I'm Janet Joseph, Urban Green board member and principal of JLJ Sustainability Solutions. We have a wonderful panel here today, including Nicole Abeen, Senior Manager, Building Decarbonization Coalition, Charlie Marino, Senior VP, Built Ecology, WSP, and Jared Rodriguez, Principal of Emergent Urban Concepts. So today we will be discussing the fundamentals of thermal energy networks, why these networks matter, and why the buzz around these pilots in the state and in the region. Later this year, Urban Green will host a part 2 conversation on thermal energy networks, and we'll dive more deeply into the topic, including into the specific projects that are under development in New York City. So why do we care about thermal energy networks? Version 1 of thermal energy networks have been around for many years, in the form of traditional fossil fuel-based district heating systems. And typically those systems had a central boiler fueled by fossil fuel. They had pipes, they had end users. But today we're talking about modernized systems that are low carbon, they're highly efficient, they're networked, and they can effectively support communities and urban environments long into the 21st century. So, at Urban Green, we talk a lot about carbon and decarbonizing our buildings. And so much of our carbon emissions in the state, in the region, is associated with heating and cooling buildings. So we do need to rethink heating. And in dense urban environments or campus type situations, a network with some centralized low carbon source of heating and cooling can make more sense. And in decarbonizing, when we look at it from one building at a time, it's a long haul, it's a slow pace. So we really need neighborhood scale clean heating and cooling solutions like the ones we'll be discussing today to decarbonize at scale and pace. So that's why we have legislation at the state level to advance real-world thermal energy network pilots. We'll hear a little bit more about that today. We have Public Service Commission orders working with the utilities to move these projects forward. We've got state facility pilots. We've got action across the region to explore this new generation of thermal energy networks. And we're doing so with some very interesting coalitions with utilities, with labor unions, with consumer advocates, with real estate, and with environmental organizations, all lined up around these thermal energy networks. So there's some exciting stuff here. Now, today, what we won't be discussing is Con Ed's STEAM system. We had a great webinar in March with Matt Ketchke, Con Ed's president, talked about Con Ed's efforts to modernize and decarbonize their district heating system. Today, we'll be looking at smaller scale thermal energy networks. So with that, let's jump right into rethinking heat with modern thermal energy networks. So I'm going to now turn to our panelists to briefly introduce themselves and their involvement with thermal energy networks. And you'll hear people in this session today call them TENs. So that's the term of art. We'll have a conversation with the panelists, and then we will open it up to some audience Q&A. So I would encourage the audience participants, if questions pop up, and you just jot them in the Q&A, and we will have time after the facilitated conversation to delve into that. So let me first pass to Nicole just to to highlight, your organization's connection to thermal energy networks. Then we'll go to Jared and Charlie.
Great. Thank you, Janet, and good morning, everyone. My name is Nicole Bean, and I am a legislative and regulatory attorney on the New York team at the Building Decarbonization Coalition. BDC works to align a diverse group of stakeholders to ultimately get buildings off of fossil fuels through policy, research, market development, and public engagement. In New York State, one of our major focuses is on advancing and scaling thermal energy networks. We have been working since 2022 with a coalition called Upgrade New York, which includes organized labor, environmental advocates, environmental justice advocates, and we're all focused on advancing and scaling thermal energy networks with organized labor throughout New York State. That's my involvement so far, and I'll pass it back to you, Janet.
Okay, Jared,
Yep. Can you guys hear me? Okay.
we can.
Okay, good. Good. So Jared Rodriguez, Emergent Urban Concepts, consulting and advisory firm that focuses specifically on buildings decarbonization, but also decarbonization at the neighborhood scale. We work with advocacy organizations like BDC and others throughout the US, national and local organizations. We work with legal aid organizations that file in rate cases on behalf of the environment. We also advise on policy and regulatory issues directly to legislators and regulators, and work with municipalities and large corporations, including utilities, to advance decarbonization strategies across their portfolios.
Great. Thank you, Jared. And Charlie?
Hi, Janet. Thanks. Good morning, everyone. So I'm Charlie Marino. I'm a senior vice president with WSP, which is a global consulting engineering firm. And I focus on building decarbonization as well as thermal energy networks. Everything from working with the individual thermal resources or customer buildings, or a developer thinking about the design elements across an entire system, which we'll be discussing today. So pleasure to be on the call with everyone.
Great. Thank you, Charlie. So let's start with sort of the fundamentals. What are the basic components of a thermal energy network? And Charlie, I know you're involved in a number of different designs, so maybe you can give us the sort of plain English narrative on what is included in these thermal energy networks.
Yeah, happy to. So a thermal energy network is a system of underground pipes that are moving either heating or cooling across different buildings. It's somewhat of a shared infrastructure in either a neighborhood or campus environment. And as Jenna has mentioned earlier today, we already have certain types of thermal energy networks in New York City, whether it be on a college campus or a medical campus, or thinking about Con Edison STEAM's network, which are truly district energy systems, which TENS happen to fall into. But these systems we're discussing today are truly low carbon focused. These buildings in plain English, essentially, and if we could share that imagery, essentially we're talking about connecting buildings that would otherwise have their own boiler or cooling system, typically intensive on the fossil fuel side of consumption and their GHG emissions. So now these buildings are moving away from those assets and connecting to a TEN. And the TEN is essentially moving either hot water or cold water at varying temperatures to these individual connected buildings, which typically have water source heat pumps that are local to the building itself. And they're utilizing the distributed thermal energy to create on-site heating hot water, domestic hot water, or cooling needs in the case of some of our multifamily buildings involved in these projects. And as you can see in this imagery, the heat injection or extraction, if we're using it also for cooling, there's a number of different low carbon fuel resources that we are leveraging. So throughout the state, we're seeing plenty of interest and use of geothermal wells, and also some other bodies of water, such as rivers and lakes, that can be utilized to both provide heat or inject heat back to the system. And then more novel, and what we're starting to see in more urban dense environments, is a focus on waste heat opportunities from buildings, wastewater systems, or even mass transit networks. And so we'll share some resources at the end of the discussion today. We'll certainly get into some of these a little more specifically in the next iteration of the series. But some of the key resources we wanted to highlight today is certainly from the goals group, the BDC is a great resource, plenty of information on not just thermal energy networks, but also how the landscape of these systems are being thought of across the nation with individual focus across states. Truly interesting work, and it's updated on a very frequent basis. So that's terrific resource that I use daily. NYSERDA also has some phenomenal programs and free information on these types of systems. There was a community heat pump program which recently sunsetted, but you could still visit that program site to see some of the studies that were established to help understand where these type of networks can exist throughout the state. And there's a current large-scale thermal program that NYSERDA has, which also has some education around that as well. And there'll be some great resources, I'm sure, coming through that program over time. And then lastly, some of us on this call were engaged with a new resource being developed, TENS.NYC. It's a great resource for TENS specifically in New York City market. So we're trying to help educate and inform both the local customer buildings that may want to participate in these types of projects or thermal resources, those that have heat that they want to perhaps reject into the system to participate. So please visit that website. We'll be updating that over time. Janet, I'll hand it back to you so we can keep the conversation going.
Sure. Thanks, Charlie. Just one quick follow-up question.
Mhm.
You talked about using waste heat, which I think is an interesting angle in the modern version of thermal energy networks. And how about data centers, right? I think that's another growing source of waste heat that we can tap into. Are you seeing that in any of the pilots in your work?
Yes, absolutely. Both Jared and I are engaged in a project that is leveraging heat from a 24/7 cooling system supporting a data center. And we're leveraging that heat into what we would consider an ambient loop that is, again, distributing that to local heat pumps for multifamily buildings. And we'll be talking about that a little bit later. But data centers are truly one of the more interesting resources across, I would say, all the cold climate zones
Right.
that we should be thinking about leveraging for these type of systems. Yeah.
Great. No, I think that's an interesting feature of, the modern version of thermal energy networks. It's all the scavenging that we envision happening as part of these systems. So when we look at these systems, even including the simplified graphic that you laid out, these are large infrastructure projects, right? These are large capital infrastructure projects. So, what are the business models for thermal energy networks? And, how do we view these systems from an urban development context? And Jared, I know you've written a lot on this topic, and even when we were both working with NYSERDA, we were kind of delving into this area. So maybe you can touch upon the business models that are under development to make these large infrastructure projects work.
Yeah, I just also have to recognize, Janet, you were one of the key instigators in this whole thing. So just want to call you out a little bit. So I think it's important to note that cities, right, and buildings, basically anything that humans touch, evolve over time, right? Nothing is ever really complete. So if we think that we're building places to a complete state, it's sort of like a myth, right? So I just want everyone to kind of take that and understand that cities change, including their infrastructure, routinely. And we've been through, at least in New York City, many waves of infrastructure renewal and radical changes. So if you think back to your grandfather's city of New York, it is not the same city that we live in today whatsoever. It's not the same city that I lived in as a child. So I think it's really important to note that. And another distinction to draw too is thermal energy networks can be as small as one building to another. It could be a grocery store inside of a multifamily building, right? The pipe run that we're talking about could be pretty short, And that could be the first leg or the anchor for a system that grows and evolves and gets larger and larger over time. So I would say, that those two sort of factors are in play with thermal energy networks. So what do I do? I'm often really thinking about how to originate projects, right? And one of the first things that you have to think about is not necessarily the technical aspect of the project, or how big a pipe is going to be or what equipment you're going to use, right? It's who's going to own the project, right? Who's going to be there from the start to make the project happen? And those might be different people, right? The ownership and the responsibility could transfer throughout the project development process. So how does a project begin? Well, I mean, you look for these thermal energy resources and you can actually map them out in a community. And then you look for off-takers that could use that heat. And sometimes the thermal energy resource itself could use its own heat to help decarbonize its own loads, right? So back to your question about business models. In New York, we passed a bill, the Utility Thermal Energy Networks and Jobs Act, that authorized regulated investor-owned utilities like Con Edison or National Grid to own and develop these projects subject to a regulatory framework that the Department of Public Service would promulgate. That bill, that was the enabling legislation for the regulated investor-owned utility. So as soon as we have a framework, right, the regulated investor-owned utility over the next couple of years could begin to invest in these systems as a means of decarbonizing their system, electric and gas, and steam in the case of Con Edison. What other models exist? Well, we've always had municipal models, and there's no legislation needed to authorize municipalities to own these systems. There are municipal thermal energy networks in New York State, like Jamestown, New York, for example, where waste heat is recovered from their own power generation system because they also own the electric network. So they have everything. So municipalities didn't need authorization. They can act today. They can bond and they can build these systems and they can recover the cost of their debt service or the bond through rates. The other mechanism that's possible is a cooperative, right? There's industrial cooperatives, there's residential communities that can function as cooperatives. That's another mechanism, right? And then the other one is entirely private, where there are bilateral agreements potentially happening between producers of heat, right? Maybe waste heat owners and off-takers. I could imagine like a big industrial park having something like that, an entirely private thermal energy network. So one of the key distinctions, and I'll just end with this, you have to understand from a regulatory perspective, where is the power in each of those models and who has power over rate making? If the entity that has power over rate making is democratic in nature, like a municipality, then there's no need for a regulatory framework because the owner is the regulator, the municipality. If the entity has no obligation to protect its customer, then there needs to be a regulator. Where there is no democratic control of the system or self-ownership of the system, the regulator should step in. And in New York State, that's the Department of Public Service with the Public Service Commission. So just want to frame that landscape out for you.
Okay, thanks, Jared. And I want to put a pin in that regulatory framework and kind of come back to that. But before we dive into the regulatory framework, I'd open this question up to the whole panel. Help us understand, what are the benefits of thermal energy networks? What are the value streams that need to be monetized to make these systems work from a financial perspective? And I'd open that up to anybody on the panel who wants to speak to it, because it seems that that's what we would need to include in the regulatory framework, or at least some of the regulatory frameworks.
Yeah, Nicole, you want to take a shot at it first?
Sure, I can get started. So when we think about the value stack of systems like thermal energy networks, I think, what comes to mind is the potential avoided cost of investment in repairing and replacing gas pipe. So a few years ago, BDC came out with a report called The Future of Gas in New York State, which quotes, the cost to ratepayers for a mile of gas distribution main replacement at around $6 million. And so if you think about investing in thermal energy networks in areas where a gas pipeline may be ready to get taken offline, and decarbonizing all of the buildings on that are currently on that gas pipeline, then you start seeing a real value in investing that money in a decarbonized solution instead of the continued investment in that gas system. And additionally, these systems have real value savings when it comes to electric capacity. So, we're talking about electrifying all of the homes and buildings in New York State. Um, that's a lot of electricity. And so building systems that have um, actual benefits around, um, avoided cost of extra transmission and extra generation would be really valuable, especially in areas that are already grid constrained. So if you think about the electric savings and the savings around the investment that would need to happen otherwise without a different kind of NPA in the gas pipe repair and replacement, you start to see the real value of investing in these systems strategically.
Okay, thanks, Nicole.
I would,
Charlie, Jared?
yeah, I mean, I would just love to drive home what Nicole said about electric capacity, right? So if we're increasing our peak demand, meaning that 15 minutes of the year where the most electricity is used in a particular area, if we go from say a summer peak in July and we increase the demand because we're electrifying buildings, then we have to increase the capacity of the wires that are there in the street, the transmission to those wires that are there in the street at that block level, any other infrastructure or equipment that's necessary to support that capacity or that peak demand, transmission regionally, and then peaking firm generation, meaning generation that's always on in order to achieve that top peak. And how do we do that in the Northeast today? We do it with oil-fired generators. So think about that when we think about increasing the peak. We need to beat the peak in any way that we can, and thermal energy networks are a key tool to do that.
So this is a really interesting point. We're talking about rethinking heat. We often think about distributing therms, but the value stack associated with thermal energy networks has a lot to do with the electric grid, the system, the generation, and what would otherwise be needed. So that doesn't always jump out in conversations, but that's what I'm hearing from your points so far.
Yeah, one other group of benefits I'd like to highlight, more specific to the customer buildings themselves. There is localized GHG emission reductions. That's pretty important, especially when we're thinking about New York City and considering local law 97 compliance and leveraging these systems for beneficial electrification and giving that some thought. Additionally, some of the main obstacles that we encounter for independent building decarbonization, electrification, essentially new electrical infrastructure in the buildings themselves, in addition to what Jared and Nicole are speaking to on the grid level. These are major obstacles that we encounter when trying to develop individual building plans, and this essentially allows us to leverage an outside thermal resource, almost outsource that to another provider and just leverage the heat that's coming in, significantly reducing the amount of interference to existing building systems for buildings that are well suited to connect to a thermal energy network. So those are some highlights as well, more at the building level.
Mhm. And Charlie,
Could I
that's
also
probably, oh, go ahead,
sorry.
Jared.
Yeah, I was just going to bring up another one. It sort of jogged my memory, Charlie, as you're talking. The value to economic development and then real estate development in general is very high. So municipalities, for example, invest in infrastructure routinely, as does the state of New York, to support economic development, either reshoring jobs and bringing industrial development, or supporting infrastructure for multifamily and affordable housing development. This is one of those tools in the toolkit that a municipality or a state agency or a utility can invest in order to create lower cost development generally in the urban area. We already have programs that make strategic investments in the electric grid, in gas systems still, in order to bring industrial development and manufacturing to New York State. So we could also be helping, for example, industrials recover wasted heat, monetize that to improve their bottom line, and support heat off takers that could receive lower cost heat than they otherwise would in their manufacturing process.
Thanks, Jared. Okay, so let's come back to that regulatory framework that was teed up in the opening conversation. So we know we've got some work underway, a fair amount of deliberations across the state. Nicole, you're sort of on the front line of the regulatory and policy developments associated with thermal energy networks. Can you tell us where we are at, or give us a summary of where we're at in New York State with respect to the regulatory framework, and what are we building toward? Because it seems like, we're talking potentially about multiple properties, utility engagement. There's all kinds of legal issues that would inevitably have to be sorted through. So where are we now, and what are we building toward in terms of the regulatory framework?
Yeah, so there's a lot going on in New York State with thermal energy networks, which is exciting. Jared talked a little bit about the Utility Thermal Energy Network and Jobs Act, which passed in 2022. And the Department of Public Service and the Public Service Commission have been reviewing the projects ever since. So the law requires investor-owned utilities to submit thermal energy network pilot projects. There are currently 11 being considered by the Public Service Commission. The final engineering plans from the utilities are due this summer or early fall. And so we're hopeful that those projects will be approved quickly after those engineering plans are submitted. And then expect the Department of Public Service to really look toward developing a regulatory framework so that this can be a more permanent project base for utilities. So right now, we've BDC along with partners have submitted comments looking to shape the beginnings of this regulatory framework. Other advocates have as well in the docket where this is being implemented. We're really looking to make sure these projects move forward quickly and make sure that there's a streamlined process for approval for them so that we can learn lessons from those projects. Beyond that, some of the issues that we're working through and some of the things we want to see in the regulations are first and foremost compliance with the CLCPA. So we want to make sure that these systems do not have combustion as a main thermal energy resource or a baseload thermal energy resource. Make sure that we're following state laws and state goals around emissions reductions as we're investing in thermal energy networks. We want to make sure that there is transparent accounting and pricing for systems and that they're operated in non-discriminatory ways. We also, Jared talked about this a little bit, but want to make sure that there is limited regulation of non-utility systems, but that make sure that regulation is focused on safety, reliability, and interoperability of systems so that as we see TENS advancing and scaling and expanding, that they can connect to each other. Utility systems and campus systems can connect and become balanced. So making sure there's regulations that require that. And then we want to make sure that there's market competition, especially for, the illustration that Charlie talked through earlier. You have to make sure that the resources, the most effective, cost-effective resources are able to plug into the system. So whether it's the data center or the bore field or the body of water, making sure that there's some competition there so that we get the best value for the system.
Jared, you mentioned that the Jamestown facility. Can you tell us what else is happening at the municipal level? We just heard from Nicole about at a high level about the utility pilots and the deliberations at the Public Service Commission, but what's happening at the municipal level? What's on your radar screen on that front? And I just want to
Absolutely.
call out to the audience, please enter, send us any questions you have so we can respond directly to you.
Great. So, question about municipalities. So the Public Service Commission and the Department of Public Service will create rules that impact municipalities. This is very
Okay.
similar to how municipalities can make their own rates for public water supply, right? But they still have rules that they have to comply with, like interoperability and public safety and testing, et cetera. So municipalities aren't fully exempt from any sort of regulation. They will have to meet certain rules. We feel strongly, or I feel strongly, that the municipality has the right to set its own rates because it is the most closely linked with the ratepayer through that democratic process. And we want to enable democratic processes, which do not exist through our investor-owned utilities. Just FYI, we have a commission that's appointed. There's a sort of indirect democratic process that governs that system. So I prefer direct democracy. Just want to put that out there. So municipalities, really interesting because they kind of have the entire value stack, right? They have control over zoning. They have control over economic development. They can determine how their main street or their community grows and changes over time. So they're in a really good position to plan for and potentially own thermal energy networks. So what's happening out there today? We have a lot of municipalities that are very interested in this topic. They're beginning to conduct planning and workshop sessions to educate their community and key stakeholders like real estate developers and business owners and industrial users, et cetera, within the community. I don't want to call out specific communities, but there are a number throughout the Hudson Valley, for example, also in Western New York, around the Rochester region, also in the Syracuse region, that are very interested in this topic and are pursuing planning. The problem is that there are no planning best practices for heat mapping or developing thermal energy networks. It doesn't exist in planner world. So I've been working with a number of organizations throughout the US, actually, including BDC, to develop context and best practices around neighborhood scale decarbonization, which necessarily includes thermal energy networks. So there's work afoot at Columbia University, School of International and Public Affairs. There's work afoot at the Columbia Climate School in Vermont with Vermont Community Thermal Networks, vctn.org. You should visit that website. Elsewhere in Connecticut, the city of New Haven is starting to conduct heat mapping planning exercises and is pursuing a large-scale thermal energy network project at its central train station. So this is coming together. We're kind of building the plane as we're flying it and learning a lot from Europe, Scandinavian countries. In Germany, they have, it's called Warmaplans. It's a heat planning requirement for cities over 10,000, where the municipality is required to do thermal energy resource mapping of heat loads across the built environment, and coming up with plans to decarbonize heating. So we have a lot of opportunity in this space, and we need a lot more people focusing on this and working on it. It's not good enough just to say we're electrifying buildings or we're using heat pumps. What kind of heat pump are we going to use? Where are we using it? How are we electrifying buildings? How are we going to make this easier so that, this happens faster? It hasn't been happening in the way that we need it to.
Mm-hmm. Jared, I want to highlight something you said. We are talking about commercially available technology, right? These systems do exist throughout North America, throughout Europe. So we're not talking about rocket science here. I think the innovation is more around the regulatory framework, around the local planning, urban development context, but the technology and the basic components exists. And I don't know if any other of the panelists want to comment to that. I don't want to leave the audience with a sense that there is so much that needs to happen on the innovation and discovery side. These are commercially available systems. So anything to add to that?
Yeah, I would say for the most part, Janet, that's absolutely correct. But when thinking about existing buildings that have the ability to interconnect and utilize these thermal energy networks, those that are currently using low pressure steam or steam heating networks, there currently isn't a great technology, although we're getting closer all the time through R&D with some of the large um, HVAC providers in the States and elsewhere throughout the world to look at low pressure steam generating heat pumps that can leverage this as well to reduce full building conversion of heating systems. But I think at the same time, when we're considering these projects, sometimes it's going to be a hybrid of a connection to a thermal energy network, and perhaps we're still looking at packaged terminal heat pumps. And I
Mhm.
think that's something that's really important and key here, especially in urban dense environments. You have to we have to change mindsets away from silver bullets and try to leverage all of the
Yeah.
potential that we have to decarbonize. And in many ways, thermal energy networks are terrific for addressing some portions of a building's decarbonization needs. Maybe it's just a domestic hot water system in a multifamily building, but not space heating. In other buildings, it could take on more depending upon what that infrastructure looks like. So those are the kind of things that we're considering on a building to building basis, network to network basis.
And
I
Charlie,
I
maybe
would
you can help.
sorry.
Oh, go ahead, Jared. And
Yeah, I was just gonna say, Charlie is describing a really interesting approach that I know NYSERDA and the Empire Building Challenge team has really been focused on. It's called resource efficient decarbonization, and it's a strategic incremental approach to building decarb, which focuses on and enabling steps that don't necessarily immediately reduce carbon, right? So how do you set your building up to be more technology agnostic so it's flexible, it could shift into the future and potentially connect to a thermal energy network when one comes down the street. Really important point. So thanks, Charlie, for making that.
yeah, and maybe it's kind of spinning off that. Let's help bring this to life by maybe talking about a couple of the projects that are under development, whether it's in New York City or across New York State. I know we'll be diving more deeply in the next conversation into the nuts and bolts of specifics, but help us bring these projects, this concept to life. So. Charlie, you're close to the New York City projects.
Mhm.
Want to give us a thumbnail of what's happening, and Nicole, maybe some of the other state projects that are un, in exploration and under development.
Yeah, happy to. So the projects we're engaged with in Manhattan, we have two U10 related pilots for Con Edison, and we are developing these projects with a number of different stakeholders as well as partners on the project team, ecosystem being very closely aligned with WSP on these. We are looking at Rockefeller Center, which is fantastic, and trying to capture waste heat there associated with their 24/7 cooling system and leveraging that heat in the context of the loops that we had discussed before to provide a heating only U10. And so essentially just capturing and leveraging these networks in connection with localized heat pumps to customer buildings to get them away from Con Edison steam and leverage these systems that where they already have hydronic heating for certain elements in the building. Um, Provide those heating services. There's another project in the Chelsea network of Manhattan. That's a really unique one. It's a building that has a commercial office multi-tenant building that has two data centers in the building, which kind of require a chilled water system to run significant amount of time throughout the year. And we're leveraging that heat to provide domestic hot water heating and space heating and even cooling. So that's like a true more ambient kind of scenario, which is fascinating. For NYCHA housing, about a block and a half away. And so that's a unique project where we're trying to leverage these ambient loop scenarios in an urban dense environment, but using waste heat recovery and also the existing cooling towers on the building to help provide those services. And I'm sure Jared and Nicole can speak about some of the other really interesting ones happening across the state.
But before Nicole speaks, I just want
Mhm.
to say the two projects that you spoke about include no geothermal whatsoever, and
Right.
people often confuse thermal energy networks with geothermal. It's not always geothermal, so just wanted to note that. Sorry, Nicole, go ahead.
No, that's a great note. And now I'm going to talk about geothermal. So you jumped in at just the right time. Um, I'll just highlight one other project because I think the ownership structure is really interesting. So National Grid has a project in Troy, and the city of Troy is actually going to develop and own the bore field and sell that into the thermal energy network loop. And so, the the UTENJA law and implementation of it is really supposed to test out different ownership models. As you mentioned, Janet, the technology doesn't really need testing, right? This is technology that we all know works. But what is interesting to test in New York State is how different owners will work together, and what those agreements look like and how they operate. So that's exciting. And then one non-utility project that we have been working, BBC, along with our partners at Upgrade New York, have been advocating for, we've been advocating for $200 million in the state budget for thermal energy networks, most of which we're asking for to go to SUNY campuses to decarbonize their SUNY and the State University of New York campuses. But some of that funding we're asking for is actually for the Jamestown system that Jared was speaking about earlier. So Jamestown, New York is a steam system, and they are the municipally run utility wants to convert that steam system to a thermal energy network. And so they are asking for funding to be able to finalize their engineering plans. And so, as many of you know, the state budget is being finalized probably as we speak, and it's looking really promising that funding for state facilities and campuses and for Jamestown will be included in the state budget. So hopefully we'll get to see that project move forward soon.
Thanks, Nicole. And certainly campuses are a very logical place for these thermal energy networks. And that's where we have a lot of the, what I'm calling version 1.0 district heating systems that need to be modernized. I want to bring in now a couple of questions that are coming in from participants. So there's a question here. It says, you're describing top-down source mapping as a first step, but also advocating for community leadership and planning. Please expand. So what type of community leadership and planning do we want to see to need to advance these systems?
Right. So I would say like mapping is helpful, but it's more helpful when the community does the mapping, because they know things that a consultant can't know. So one of the first steps in engaging with the community is we identify what existing social groups are there. Is there a sustainability committee? Are there other local advocacy organizations involved that are already thinking about something like this? Is there anyone that has done geothermal or decarbonized their building in the community that could be a champion? And you bring those folks together early and begin to explore the idea of making the tent bigger through a workshop or a public planning session. And so through the workshop, you're bringing this concept, not literally, but its basic parameters to the community so they have a working knowledge to deploy basically pre-development work on their own. Right. So like we don't have to keep all of this so close to the vest, right? We need to be teaching people that recovering heat is possible and it's possible to share it. And that very basic idea is very powerful in getting people to organize. So what happens, like as soon as you do that workshop, and I encourage folks to have maps at the workshop, markers, people actually working together to think about this. You immediately, by the end of the workshop, see clusters emerge out of the urban area. It could be part of a main street. It could be an existing campus. Maybe it's a public school campus. Maybe it's a municipal campus. It could be focused on an existing thermal energy resource like a wastewater treatment plant in an industrial park where there's heat users and other heat producers. So the community knows the best about their own community, empower them to identify where the most actionable projects could occur. You've created buy-in from the very beginning instead of coming in and telling that community what they're going to get, which is never a good idea.
Right.
So yeah, so that's what I mean. It's not top down, it's bottom up and top down simultaneously, using middle agents or people that act and pull together the threads that comprise a community.
Okay, thank you, Jared. So, question here, are TENS necessarily a public sector or utility sector infrastructure, or have you seen interest in privately developed buildings? And Charlie, you're probably involved in a few of those. Maybe you could speak to what's happening in the privately developed real
Sure.
estate space.
Yeah, and certainly Jared, Nicole, please feel free to jump in too. So, the projects that we have underway here in New York State, New York City, are utility-owned thermal energy networks, hence the UTEN name. And, it's very helpful, especially in New York City, where in order to get a pipe from A to B, you need someone that has some pull and weight in the city to kind of expedite permitting and get things moving in the best means of pathways. And I think the utilities are in across the municipalities are really well aligned with that for that component of it. Um, but I think also, when looking at some of the other thermal energy networks that exist in the world, and even looking at our neighbors to the north in Canada, you see certainly privatized developers moving forward with these projects or creating public-private relationships to move these further with municipalities. So I know Jared had spoken about those prior. Um, but yeah, certainly I think utilities are certainly being utilized for the first endeavors across TENS in each of the states that are pushing this, especially in Massachusetts, New York, and of course in Minnesota now. But I think they're really being utilized to help truly pilot these concepts so others can see what can happen, and then also allow these developers who are paying attention to seeing how they're executed and how they can participate in the local markets as well. So I think, to your point, district energy version 1, pilots version 2, I think version 3, when we have a lot of lessons learned here across the state, we're going to see a number of other players getting involved too to help us accelerate these type of networks.
Great.
Could,
So there's a
could
question
we
here
pull
on
up that
cost, and
could we pull up that image just to kind of maybe illustrate something that Charlie said? Would that be okay? Like the thermal energy network image. Yeah.
there
Okay.
we go.
So really quick, really very quick. Nicole mentioned this earlier that we have a multitude of possible players and we want them all involved to drive costs down. Right. We need competitive markets that deliver thermal energy at competitive cost, right? Which is generally how the electricity system is supposed to work. So what there is here is what's called a common carrier, right? Which is an entity that basically just charges a toll to move the commodity or just to move the heat. So the purple is an ambient temperature loop. That's how we're showing it here. That's the common carrier. That could be owned by a regulated investor-owned utility. It could be owned by a municipality. It could be owned by some other entity. The merchant activity, right, is the thermal energy resource developer and supplier of heat or cool or storage on the system. So as a limitation emerges on the system, maybe because new customers want to come on, maybe because there wasn't the right estimation of the thermal energy load, the common carrier can go out with a tender or a solicitation to ask for a very specific performance profile from a resource provider. And the resource provider could be anyone. as long as they're willing to meet that specific or those specific parameters for a cost that's competitive. So that's how we've shown it here. There's regulated activity and unregulated activity. This is an opinion right here. There are a lot of opinions that are being created about how this framework can work. But outside the dotted line, unregulated activity, inside the dotted line, regulated activity, and then interactions between different types of thermal energy networks, hot, cold, ambient, etc.
And Jared, what you're describing is analogous to our electricity deregulated system, where you have a central entity saying, hey, generators of electricity sell into the system. There's a little bit of an analogy here. You're saying, hey, providers of waste heat, sell your commodity into the system. So I just sort of throw that out there because we often think about that electric utility model. I want to touch on cost because that's a really important element here. Question, how much of the cost of the infrastructure and HVAC system conversion in a thermal energy network can be recovered via a competitive TENS energy cost? Can they be fully economically self-sustaining? Do they need public support at this point? So that's a question from the audience, and I open it up to the panel to address the topic of cost.
Yeah, I can jump in and start. I think a good illustration of how these systems are cost effective is the State University of New York work. So we've worked directly with SUNY campus energy managers who have decided that they want to build thermal energy networks because they see the payoff of these systems. And so you'll see a higher capital cost investment, but over time, the operational costs become less than it would be to decarbonize through other measures. So, for example, the University of Albany is building a thermal energy network. That was a decision that they made based on cost effectiveness, the best way to decarbonize their campus. And New York State has already made commitments to decarbonize all of their campuses. So now it's really figuring out how. And you're seeing, especially with diverse loads and campuses have the benefit of single owners from multiple buildings, it's a little bit simpler. But you're definitely seeing that cost competitiveness. And then the University of Buffalo energy managers did an analysis, and they were working with their utility who said that if they wanted to decarbonize with air source heat pumps, they would have to actually increase the amount of electricity that they were able to receive, build out transmission. But if they were to decarbonize with a thermal energy network, they can decarbonize with the current amount of electric capacity provided to them. And so that is a huge cost savings for that campus. And so it's really important to look at the value stack that we were talking about earlier to understand like the payoff period for these systems, especially as we're looking at potential grid constraints in specific areas.
Any other comments on cost? And when we talk about the specific projects in our part 2 conversation, I think some of that will become more clear because the answer on cost is always, it depends, right? So
I mean, every project is different, and it's just gonna be get over it, right? Like a lot of people want to make blanket statements about this. Every single project is different, just like every single water or sewer project in every municipality is different. So this is not cookie cutter, okay? This is a different type of approach. It's like building out roads, waters, sewer, etc. I have seen municipal projects pencil in that the rates that are recoverable through the thermal energy network through heat sales cover the debt service on the bond. So there's no tax impact. I've seen projects where it covers more than the debt service on the bond. So that means that the community is able to, for example, hire a new FTE for the Department of Public Works, for example, right? So what are the buckets of value that you can extract inside the building, outside the building, across the entire infrastructure network, right? All commodities in order to make this system work from a total life cycle perspective.
Okay, I think we have time for 1 or 2 more questions. So I see there's a question here on supply chain opportunities. Do you see any supply chain opportunities for locally owned business, for example, in New York City? So love to get your quick thoughts on that.
Charlie, why don't you take that right now?
Yeah, sorry, Janet. I was reading through the questions. Can you repeat
Oh,
the question one more time that you were calling
yeah,
out? Yeah.
I'm teeing up the question on supply chain. Are there any supply chain opportunities for locally owned businesses in the thermal energy network space for some of the New York City projects?
Oh, certainly. I think we are there's some unique materials that we're leveraging within these U10 systems, but at the same time, the typical trades that would be involved with any type of HVAC upgrade, pipe fitting exercises, those are all a big part of how these move forward. And in terms of the equipment that we're utilizing, for a number of these U10 projects. They are domestically available heat pump technology that are repped locally and manufactured in the States. In some instances, for the higher temp hot water scenarios, those are currently more so from overseas. But yeah, there's plenty of opportunity in this domestic facing world that we have to live in. So I think that's only going to expand over time.
And local
I
labor,
And
Oh yeah,
right?
yep.
Like
plumbers. I mean,
underscore the local labor
Mhm.
point.
we knew we needed plumbers before this, and we really need plumbers now. I
Yes.
just want to like call one thing out. Like, I didn't realize that pipe fittings were generally not made in the US. Like, copper pipe fittings are not made in the US anymore. So that is a pretty big problem. So anyone that wants to make pipe fittings, manifolds, all of this stuff in the United States and preferably in New York State, I think is pretty welcome to do it.
Mm.
Great. Okay, we're going to do one quick question and then back to Daiva. The pilots require construction and impacts on residents, customers, and businesses. How are these stakeholders reacting, responding to these projects? How are they being engaged, and how do we get them on board? I don't know, Nicole, if you have any thoughts on that, and that this will be sort of our closing question around stakeholder engagement, which is so important for projects of this scale.
Sure. I know that utilities, we've been working with Con Edison. I know Con Ed has been doing a lot of work around stakeholder engagement, specifically in Mount Vernon. Lots of conversations with folks who live in that area, and getting people excited for this transition. Truthfully, because of the staged approval process at the Department of Public Service, there's no clear indication of the project moving forward at this point. So customer engagement and community engagement is difficult because there's no like, and we'll come and transition your house on X date, right? It's like, if we're doing this, would you want to
Mm.
participate? And so that leaves the community just a little bit more unsure than they would be in a process that left a guarantee. And so I think that question is, if I may, a particularly good one to ask utilities or folks at the next conference when there's consumer protection plans that utilities have created, and when they've been able to have a little bit more engagement in different communities. Although I know utilities are doing a lot of that work now.
Okay, well, we will flag that as something to delve into further. And I do see we're at the top of the hour, so I want to thank the panelists for sharing your insights and the participants for engaging in this conversation, and hope to see you all later on this summer at the part two conversation when we can dig into some of the specific projects that will be going forward in New York City and the region. So with that, again, thank you. And I pass it back to Daiva to close on behalf of Urban Green.
Thank you, everyone, and thanks for a great webinar, Janet, panelists. I've really enjoyed this one. Um, I think if you like this conversation, you might also enjoy our conference. So on June 2nd, at the NYU Kimmel Center, Urban Green Council will be holding our annual conference, New York City Next, Shaping Building Decarbonization. We'll have three excellent panels and a keynote by Rory Christian. Also on our event calendar, we have Match Made and HVAC, choosing the right heat pump for your building, a variety of energy code trainings, and our Urban Green Gala, which will be held on October 7th. So you can find all of this on the events portion of our website, and we'll also email everyone who attended this webinar to let you know about the next in our Thermal Energy Network series. So thank you for attending, and thank you again to Janet, Nicole, Jared, and Charlie for a great webinar.
Take care.